Welcome to Cisco Live. Today, I am going to share the insights about mastering SD access fabric-enabled wireless. It's going to be an advanced session. So expectation is that you all are having basic to intermediate knowledge on SD access and wireless. Here in this, we would be covering PacketWalks and deep dive troubleshooting. At the start itself, I would like to request everyone to download the WebEx app and ask any questions if you are having any. I would be there monitoring this till tomorrow. And towards the end of the session, we would be taking all the questions. So please park your questions towards the end. In between, if time permits, then I would be taking some questions and will be asking some. Before getting into my introduction, just want to ask quickly, are you aware of a South Korean MNC which is into electronics manufacturing, apart from Samsung? Like it manufactures refrigerators, phones, everything? Anybody? It's a big MNC. LG, right? My name is Lakshmi Ganesh Kondaviti. My friends call me LG, okay? I'm a senior technical leader in TAC, looking after software-defined access and Catalyst Center. In day-to-day life, I look at customer escalations. If you see me on any customer escalation call, then it's an escalated one, okay? And apart from that, I also work on innovations, inventions. I do have 4 patents. You can Google me. And one of my inventions is on SD access, okay? Apart from that, I do have 2 CCIEs. And if you can look, that's almost 10-year-old photo, right? And right now, if you see, I have lost all my hair thanks to troubleshooting, right? So, but yeah, I'm really happy to share my knowledge today out here, standing in front of you. Thanks for this opportunity to Cisco and you all. When I was preparing this session, I was having these questions. Why fabric and why wireless, right? And how the packets are traveling over there. And what if something breaks and what I need to troubleshoot? So this was the thought process for preparing this slide deck and this session. At the outset, I would like to request again to please download the slides, because as we go through inside, we would be requiring this. You have to refer back all these slides because there is a lot of correlation, okay? So please do download these slides. Now, moving into the agenda. So here, we would be covering briefly about architecture overview. Main focus would be on basic workflows and troubleshooting. Here, we would be covering 3 different workflows: AP join flow, client onboarding flow, and client roaming flow. Apart from that, we would be looking at some common scenarios and troubleshooting tools, the CLIs, which you can use. So, and we would be ending with best practices at the end, okay? So that's the agenda. So where do we start, really? So we started with legacy network, legacy wireless, right? And obviously, we have moved on, but we have seen some problems out here, right? What were those problems? I just enumerated some problems, namely ease of deployment. Let's say if you want to deploy a particular ACL across the network, then you just have to go on each node and deploy it. So there was no ease of deployment in legacy network. Not only that, stretching of VLANs. Just imagine, I am in this building, I want to move to next building. In that case, I have to stretch my VLAN or my network over there. And in that case, we can see L2 loops, right? The stretching of that VLAN would be a bit cumbersome task. So that's where mobility is, again, having a problem. Not only that, in fact, if you look in deep, then you will see the IP and location are tied together traditionally. Can we, untangle both? So with that, we can actually get a lot of benefits, right? Like deploying the policy, irrespective of IP and IP pools, that we were not getting in legacy network. And finally, the network segmentation. We can't do the network segmentation, in an efficient way in legacy network. So these are some of the problems. Please do keep these pointers in mind, because we would be referring back again and again. And this would be a navigation point for us. So how we can solve? With Fabric. With Fabric, all these 4 pointers, the difficulties which I have enumerated over there, those would be addressed. So let's see how SDA Fabric, SDA Access Fabric, and wireless integrated together is solving that. So we would be taking a brief overview. So we are having 3 controllers. Here it's a solution, right? And we are having 3 controllers like Catalyst Center, ICE, and WLC. All these 3 controllers are integrated together. Here, automation part is taken care by Catalyst Center. So the Catalyst Center is helping with ease of deployment. And policy part is being taken care by the ICE. Here, as I mentioned, WLC is integrated with DNAC or Catalyst Center and ICE. So that gives us operational advantages of all Cisco Unified Wireless Network. And this WLC is integrated or having Lisp connectivity with control plane nodes. Control plane nodes gives us that functionality where it is acting as a brain of the network, brain of the fabric, right? So with that, mobility is integrated, and thanks to this Lisp control plane. Not only that, it helps us with optimized distributed data plane. So here, what happens is the Anycast gateway is spread across all the fabric nodes, fabric edge nodes, right? So due to that, we are getting that gateway all across. And that's where the stretching of VLANs is addressed. So it's so simple, no loops, right? With that, all L2 roaming we can have. And not only that, the last 2 things, the carrying of policy and network segmentation, that itself starts from the edge, because we are having the access tunnel to carry those policy and network segmentation information in the form of SGTs right from the edge, right from the AP, right? So that's how we are addressing all those problems which we have seen on the first slide. Now, let's get into the quick overview of design and deployment. Here, I would like to point out the latency figures. This is very important. Many times, I have seen in the field, after some years, right, it gets uncovered, or maybe during the deployment it gets uncovered, that latency figures are not taken care. So we need to take care of latency figures, while all the latency figures in green are common for the SDA fabric. I would like to highlight you about the latency figures between control plane node and WLC. It should be 100 millisecond RTT, round trip time, right? And between WLC and access point, we should have 20 millisecond. So these are the requirements. Please do keep in mind while deploying new network, or even if there is any degradation afterwards. So it gets uncovered after a few years also. In fact, I have seen that, right? So please do take care of this. This is very important. Apart from that, the first and foremost thing, what we have to do is, we have to integrate our WLC into the fabric. And what we do for that, there are 6 things which we do to get our WLC into fabric or make it fabric enabled. What are those things? Creating the design. That is the first thing. Second, creating the network pools on the Catalyst Center. Third, creating the wireless settings. So these are creating about 3 different things for our intent. Fourth, we would be getting discovery of the WLC. There are 2 ways to do that. Via SNMP and CLI, that is one way, or second, it could be PNP, right? So after that, we have to provision. That's the 5th step, provision the WLC. And 6th one is fabric provisioning, where we provision it to get the WLC into fabric. So once that is added into the fabric, we just have to check. How we can check? We can check here, going into configuration, wireless fabric on the WLC graphical user interface. And from there, we can see over there, it's enabled, right? So, and from there, we can also see that what are the CPs, control plane nodes, which are added into this WLC. So that's how, WLC is added into the fabric, and it is integrated with the control plane nodes. Now, till this point, are you there with me? Right? So now, have you heard this anytime? Ting, ting. Yeah, please fasten your seat belts. We are going to take off, and there could be turbulence. So please be seated and have your seat belts fastened. Have you heard about this? Right? In the flight? So from here, we are going to fly. We are getting into more details, right? So here, I want everyone to pay the attention for next 40 to 45 slides. I promise, once you go through this, all those 3 basic workflows which we have seen, you would be getting hold of it like a TAC engineer, as we have seen in the title slide, right? So please do pay the attention. Sometimes there could be turbulence where it would be a bit difficult to understand. Please do refer to the slides, which you must have downloaded already, or you can look at the slides out here and try to correlate, right? So now moving on. AP join onboarding flow. Before getting into that, I would like everyone to pay attention to this topology. This topology diagram would be a navigation point for us, because many MAC and IP addresses we would be referring while we go inside, okay? So here, I am having 3 controllers, again, Catalyst Center, ICE, and WLC. So WLC is integrated with the control plane nodes and also other controllers, right? So it's having Lisp session with the control plane nodes, which are named as SJBDR1 and SJBDR2. Those are having the loopback IPs. I have just noted down the loopback IPs over there. If you want to take a picture of this, please do take it, because we would be referring to these details many times. Not only that, we do have 2 fabric edges out here. That is edge 1, SJ edge 1, and SJ edge 2. Each edge is having 1 EP each. That is SJ edge 1 AP2 and SJ edge 2 AP2. We would be focusing on SJ edge AP2 and this part. And for roaming, we would be using this part, okay? So here, we do have the client also, the wireless client, which is there. So for that, I have just mentioned the IP and the MAC details, which we would be getting as part of the flows which we are going to see. Okay? So this is very important out here. Now, from here, we are getting deep and deep. Okay? So please fasten your seat belts now. Right? So AP onboarding flow. So here we do have various components involved as part of the solution, like AP, Fabric Edge, ICE, CP, that is control plane node, WLC, and DHCP server. Not only that, in the background, we do have Catalyst Center, right? The Catalyst Center has deployed the network. That is the assumption here. And once the Catalyst Center configures the IP pool and the deployment is done, so here that IP pool is part of infra VN. Please take note of that. It's part of infra VN, okay? Once that is done, now just imagine, I'm just trying to join my AP. It could be new joining process, or it can be as part of, existing one where it is again rejoining, okay? So at that point in time, what happens? AP gets powered on, first of all, and then it connects to the Fabric Edge. When it connects to the Fabric Edge, first of all, what happens? AP authenticates and authorization happens, where, first of all, it connects to the Fabric Edge, and that packet of authentication and authorization is sent across to the ICE, where it gets authenticated and authorized, and, AP gets to know about it, the Fabric Edge, via Fabric Edge. Now, what happens? From there, once that process is done, this AP gets the DHCP IP. It initiates the DORA process. What is DORA process? Discover, offer, request? Right, request and acknowledgement, right? So the DORA process starts, and AP gets the IP from the DHCP server. And this is very important point out here. It learns about WLC IP also, like in traditional network, right? Where we are having 3 different options: DHCP option 43, DNS, and PNP, right? So here, in this, we would be depicting about DHCP option 43, okay? Now, once that is done, because the Fabric Edge is having the information of that IP which is allocated to the AP. How it got that? Via DHCP snooping. On the Fabric Edge, it is having DHCP snooping. So from there, it got to know that AP has got this IP. And from there, after updating the device tracking database, it just informs the CP node. How it informs? It informs via Lisp map register, where it registers both MAC address and IP of the AP, okay? And around the same time, at the same time, parallelly, AP joins WLC in local mode. And what happens? WLC looks at that join and see, okay, if this AP is Fabric enabled or Fabric capable or not, right? Is it Fabric capable? How it checks? There it looks, is it wave 1 or wave 2 AP or not? So once that is checked, then it goes to the next step, right? Yeah.
In terms of the option 43 in the DHCP, what is the preference? For an example, at the moment we have a voice legacy and SDA network in our environment, but we are migrating from legacy to SDA. And we are following the PNP process to get migration of all the APs. So do you recommend to put an IP address of WLC or the DNX center?
Yeah. So the question of the lady is, what is the preference of the DHCP IP and how we should put that? We would be, discussing that going forward. Please, keep that question for now. We would be discussing that. If you don't get the answer in totality, I am here after the session. I would be taking all the questions, okay? So, again, we would be covering that. So now, here, So once it goes to the next step after that. So what happens after that? Now WLC has got to know about the AP, right? And it has already formed the CapWeb tunnel with the AP. But WLC don't knows about where this AP is connected. I mean, at back of which fabric edge. For that, it sends the Lisp map request to the CP, because CP is the brain of the fabric, SD access fabric. From there, it gets to know, because as you can see, just in the Lisp, FE Lisp map register for AP, IP, and MAC, there it got to know about that. CP already got to know about this. And from there, it gets the, it goes for the request and gets the AP, IP, RLock, where this particular AP is connected. And from there, again, after getting to know, now the entire process of forming of access tunnel starts from here. Why access tunnel is required? For the carrying of policy and network segmentation information, right? So using the base radio MAC of the AP, WLC sends another Lisp map register to the control plane node. Once upon receiving that, CP sends a Lisp map notification, just forwards that to the fabric edge. And once the fabric edge gets to know about this, it is the base radio MAC of the AP itself. Then it knows, oh, this client which is connected at the back of me is actually AP, and I should form a access tunnel with that. So that's where access tunnel forms and AP is onboarded. Are you all with me on this till now? Yeah, I take that as yes. We would be getting into more details. So here, AP DSCP flow. So you would be getting your answer out here. So here, we can see the DORA process. We would be looking at the offer out here. So in offer, we can see the IP, which is ending with 85.85, that's being offered by the DSCP server. And not only that, we do have option 82 out here. In option 82, there are two different components which are very important. One is the agent circuit ID, right, where we get the VLAN information, and agent remote ID. Here, we get Lisp instance ID and remote locator. Remote locator is the RLock or the fabric edge, where it needs to send back. Because we are having Anycast gateways, right, in the fabric. So for that, these things are required. Now comes the important thing out here. So this is the option 43. In the option 43, that hex code, when we decode, we'll get the WLC IP, right? So this is one of the options. There is no priority or as such anything. You can use this option or the other one, which we discussed. That would be used for PNP, okay? So that's how we can do the things.
Because in the legacy, so we are doing multiple projects. So where we are just doing in legacy environment from wave 1 AP to a 9130s or 9000 series basically. That's where we use the PNP, that pointing out to straight away WLC, just because our WLCs are not managed by the NX center in the legacy. Whereas in SDA, it is managed by, so we are pushing to an Catalyst Center as option 43 preference. So that's why I just wanted to understand that we have tried both the method. Which one is the preference?
There is nothing as preference over there, as you mentioned. So you can choose any one, but choose one. Don't mix and match the things. That way, there could be a problem. Sorry?
Then that's not going to work, right? So you need to use DNAC as your option 43.
That is for P.
DNAC will tell the AP which wireless controller.
No, that is option. That is for the PNP. As we have seen, just I would like to show you that there are different options, right? DSCP option 43, DNS, and PNP. So in PNP also, we can use that. And also, if we use the option where you are putting the DNAC IP, there it gets into the DNAC, and from there you need to provision again. But here, I'm just talking about having the WLC IP as part of the option, this DHCP option 43, and it works, right? So I will show you more details. You can look into the PacketWalk out here, and from there you can make it out. So here are the live proofs which I have taken from the network itself, right? So once the DHCP process is done, as if you remember, AP joins the WLC. And what happens over there? When AP joins the WLC, there is the exchange of certificate, okay? And it joins in local mode. And from there, you can see, after exchange of certificates, we do have CAPWAP forming over there. So once that is done, in the parallel, as after DHCP, Fabric Edge got to know about the AP IP from the DHCP snooping. So it goes for the registration of the AP, IP, and MAC, right? So here is the registration messages. If you can see, I've just blown it up out here just for your information. So from there on, as WLC has joined the AP already after the checking, right? That is it Fabric capable or not? Checking like, is it wave 2 or wave 1 AP? After that, what happens? WLC don't know about where this AP is connected, at the back of which Fabric Edge it is connected. So it goes for the map request, Lisp map request, and asks the CP. From there, it gets the reply. What it gets? The locator IP, okay? So from there, again, after that, the entire process of forming of access tunnel starts, where WLC just sends a map register to the CP with base radio MAC. If you see here, this one, the base radio MAC, and the client SGT and other information. In some Wiresharks, we may not be having required dissectors. In that case, you may see this to be WLC registration, type to be 31, okay? This may not get resolved as WLC registration, but just type 31. And one more important point, AP join would be set to 1 in this case. Once that is done, CP receives the map register with the base radio MAC. And once it gets that, it just sends the map notification to the Fabric Edge. Here we can see the message type 21 and with the radio base MAC address. Once that is done, FE receives the same message, and then it forms the VXLAN tunnel, okay? So that's where AP finally joins with the access tunnel forming. Are everyone with me till this point?
I've got a question. So why does it use the radio MAC line of the Ethernet MAC? Is there a reason?
Yeah. So first of all, when AP, it can be any dummy MAC also. Here in this case, AP is having two different MACs. One is the physical MAC, and another one is your radio MAC, base radio MAC. So what happens is, first of all, when physical MAC is learned via, when it connects after powering on, then it learns from there itself. And it treats that as a wide client, any other wide client. Now, how it will come to know that it is AP and I need to form the VXLAN tunnel? For that, it uses the WLC, sends that map register message with the base radio MAC, because it's already know the base radio MAC as part of its joining process. That's why it uses that.
So that's why we see on the DNAC only the radio MAC. We don't see the Ethernet MAC.
Yes. So from there, it gets, your Fabric Edge finally knows about that base radio MAC, and from there it forms the access tunnel. So that's the reason. But it need not to be base radio MAC. It can be, dummy MAC also. But in our implementations, we do use base radio MAC. So that's the thing. Now, when something breaks, right? Do you get into this mode? Right? So many times I have also got into this mode, right? But after this understanding, like how the things are happening, you will not be getting into this mode. Let's look at the troubleshooting part. Okay? In this troubleshooting part, I just want to set the rules stating we would be covering different components. We would be just hopping onto the different components and see what is the expected output. Okay? From that, you can always check back in the production environment if you face any problem, what is the difference, and make it out where the problem is. And bit of correlation also needs to be done. That comes with bit of experience. But once you see the things, you will also get to understand like what all we need to check as part of this troubleshooting. So that's the idea out here. First and foremost, Catalyst Center is our controller, right? So we will be checking, starting with the controller. Where we will check? We'll check in the assurance dashboard, in the device 360. So we can go to the device 360 and check if the physical topology is okay. And are there any alarms? Are there any events? In the event history, in the device 360, we can check that. Okay? Not only that, if I want to get inside the device from the Catalyst Center and see or run some commands, how I can do that? I can do that from the command runner. I have just posted the navigation over here. We can just follow through and get over there. Catalyst Center is responsible for the deployment, for the configuration, right? So on Catalyst Center, the configuration parameters should be in a good state before any deployment. So here, it is very important that infra VN out here is having, required AP pool mapped over there, and it is having the VLAN ID and L2VN ID mapped over there correctly. So once that is done, we can hover over the VLAN name and see what is the VLAN name. This is very important. I will tell you why it is important in the next couple of slides. So here, once the Catalyst Center deploys it, where it deploys on all our fabric devices. Let's look at the fabric edge. So on the fabric edge, we can see the VLAN is deployed, okay? And the VLAN name. Why I said the VLAN name is important. That VLAN name is mapped in the authorization profile on the ICE for the authentication. Let's say if you're using .1x or MAB, in that case, this exact name is mapped in the authorization profile. And that's really important out there. Not only that, we just can check the running configuration which is deployed. We are having this DHCP server. We would be referring to this 84.8 throughout our session. And here we have Lisp mobility, which is very important for the learning of dynamic EIDs. So these things needs to be noted. I've just highlighted everything out there which needs to be taken care. Now, we can also check at the running configuration of the Lisp. With this command, we can check the running configuration of the Lisp and see if L3VNID is having the mapping of that particular IP address pool, and L2VNID is having that VLAN mapped. This particular VLAN 1027 is the AP pool VLAN. Okay? So, not only that, once that is done, it is very important that Fabric Edge is having DHCP snooping enabled, because from that only, once upon AP gets the IP Fabric Edge gets to know with this snooping that, okay, AP has got the IP. And that snooping should be enabled for that particular VLAN. So that's very important out here. That is one check. Apart from that, in the show IP DSCP snooping output, we should see the IP which AP got and on which interface it got as part of which VLAN it got. And is it the same VLAN which AP pool is having? So that is important. And the most important thing out here, and my favorite command as part of Fabric Edge checks, is show access tunnel summary. So this gives me the details about the AP IP, where it got connected, what's the destination port, and important point out here is the uptime. Uptime is very important. Sometimes, while troubleshooting, I have seen that AP is all stable, but access tunnel could be flapping. So in that case, it's very important to look at this uptime. Is it stable? There are few more commands which I have posted in the PDF, but hidden out here. Those are platform commands on the Fabric Edge. You can always refer. It is having all the labels, as in this case. So from here, we will be going into WLC checks. So on the WLC, we would be seeing first is the fabric enabled, right? In this command, show wireless fabric summary, we can see if fabric is enabled or not, and Lisp sessions are up between the WLC and the CPs. And not only that, here it is very important. If the VLAN VNID mapping is done, and it is having corresponding L2 VNID and L3 VNID along with the IP address pool. So this is something which we need to take note of it. Here it is for AP pool. This above one is for the client pool. We will see when we look at client onboarding. So these are some of the things which we need to look at. Now, many times while AP onboarding, we see there could be a mismatch of the country code, right? So how we can see that? We can see in show fabric AP summary. So in that, we can see what is that AP name, and if it is registered or not. And one more checkpoint is control plane node. In the control plane node, we can see in the show Lisp session output if Lisp sessions are up between CP and WLC and the fabric edges. So that needs to be up. And we can see the uptime out here also, right? So on the CP, we can see this one particular command, which is very useful while troubleshooting, where show Lisp instance ID, Ethernet server address resolution. It resolves and shows the mapping between L2 VNID, L3 VNID, and the host address. The host address out here is AP address and AP MAC. That is a hardware MAC, okay, not the base. So that's how when CP gets to know about that, so we can see that resolution out here on the CP out here. And the second one, show Lisp site. In that we can see when it got last register, is it up, who registered it, here who registered it, that is the fabric edge which registered it. So that's what we can see out here, and what is the L3 instance ID and the AP IP, that is the EID prefix, that is treated as the end client out here. So now, finally, we are talking about AP onboarding. Let's say if I want to check on the AP, if it is onboarded properly, and what I need to check. In that case, show IP interface brief. This tells that what is the IP it got, through which method it got, the DSCP, through DSCP it got, right? And what is the speed and duplex. These are some of the important things to check. Not only that, show controllers wired 0. This also gives the same information. Apart from that, show IP tunnel fabric. This is very important command, where we have to look at this adjacency status forward, and encap should be VLAN, VXLAN. So these two things needs to be noted out here. So with that, we are at the end of AP joining flow. Okay?
Is the authorization with ICE necessary for the AP, or can you just skip that part?
The question is that authentication authorization necessary? No, it is not necessary. If you want to have the static one, then you can have that. In that case, ARP snooping will help to detect and then inform the CP. Fabric Edge would be using ARP snooping instead of DSCP snooping in that case. Okay? So now I would be moving on to the client onboarding flow. Just before that, I just want to ask a quick question. I do have some souvenirs. AP joins which VN? Intra VN. So here are your souvenirs. I would like to. So here, we would be getting into client onboarding flow. Client onboarding flow and roaming flow are quite similar. Okay? So please pay attention to the client onboarding flow. From this, it would be very easy for you to understand the roaming flow. Okay? So now, let's quickly move on to the client onboarding flow. Here again, like in case of AP onboarding flow, we are having different components. Like client, obviously, it's there. AP, WLC, ICE, the control plane node, Fabric Edge, and DSCP. Right? So, first of all, what happens? I am having a client. It would be seeing when you, turn on your wireless, it would be seeing the SSID or WLAN, you can say. So we have to just connect to the Fabric-enabled WLAN or SSID. So from there, the association and authentication happens. So it connects to the AP, and from there, it is forwarded to the WLC. And looking at those association and authentication requests, WLC sends it across to the ICE, and upon successful authentication and authorization, this client would be on. And from there, what happens? The WLC sends the Lisp map register for the client MAC, informing the CP that, okay, I have got this client. That client is trying to join in, and it got authenticated successfully, right? So from there, CP gets to know that, okay, the client has came in, and here WLC is acting as a proxy, okay? So now, it proxy registers out here. And from there, the same information is passed to the Fabric Edge. So Fabric Edge also knows via this Lisp map notification, and it updates its L2 forwarding table out here. In this information, there are 3 pieces of information which are being forwarded or sent across to the WLC, to the CP from WLC. So what are those? SGT information. Second, L2VNID information. And third is the RLOC of the AP, from which AP it has learned that, okay? So these 3 pieces of information are sent from the WLC to the CP, and that same thing is forwarded to the FE. So as part of that, SGT is forwarded. SGT is known to the Fabric Edge right now. From that, it downloads the policy. It reaches out to the ICE and downloads the policy. And if the permissions are there, then it will be going through to the next step. That is, client goes for the DSCP process, the DORA process, and once the client gets that, due to DSCP snooping and other things, Fabric Edge also gets to know about it, and device tracking database is updated. Once the device tracking database is updated, it informs, Fabric Edge informs the CP, saying, okay, this client is connected at the back of me via this AP, and CP gets to know about it. Around the same time, AP also get to know. So AP sends that to the WLC. And from there, the client gets into the run state. And once it gets into the run state, the device tracking database on the WLC also gets updated. So that's the final state. Are you all with me till now? We would be getting into more details out here, right? So this is how the things happen. Now, let's quickly move to the flow. What happens? First of all, the association and authentication happens. We have taken this on the WLC. So if you see, it got connected to the SJ Corp SSID, right? And then after, further EAP and EPOL messages are being exchanged. EPOL, radius messages are being exchanged for the authentication, authorization, and then after this EPOL messages, maybe someone who is into wireless, they can acknowledge this. These are M1, M2, M3, M4 messages, right? So those are exchanged. Once that is done, so here, Lisp map register is being sent for the client MAC. WLC informs the CP about the client MAC. So this capture we have taken on the WLC, and from there we can see that this information is being passed, where we can see the client SGT, right? We can also see L2 VNID information is there, right? And this is the WLC registration message, type 31. As I mentioned earlier, in some Wireshark or freely available Wiresharks, sometimes we don't have dissectors. Okay? In that case, you will just see this Lisp registration type to the 31, just 31. So from there, you can make it out. I have just blown it up, right? We can see SGT information, L2 VNID information, and the RLOC information are being sent.
Here, the RLOC is going to be the access point, right? At this point in time,
Fabric edge,
local RLOC.
right? Where the AP is connected. This now, okay?
FE, right?
Yes, FE, okay? Where the AP is connected, through which the client has came, right? So these three informations we can see. This same thing we can see in the array traces also, right? So in the array traces on the WLC, we can get this information. The association happened with that particular SSID and the radius exchange, where we can see the access accept finally once the authentication happens, authentication and authorization happens, right? From there on, we can also see M1, M2, M3, M4 messages being exchanged. And the register, WLC map register, for the client MAC which is being sent and the WLC map notification which is sent. We can see that as well in the array traces. So from there, the notification is being sent from the CP to the fabric edge once after getting the map register, right? So here we can see the registration message is received, and then the first packet, you can see the registration message is received, and then a map notification is sent towards the fabric edge. This is the map notification, right? So the same map notification is received on the fabric edge, and at the same time, the client also initiates the DORA process. So here we have taken the captures on fabric edge uplink. One important thing to note out here. What is the SGT? What is the SGT out here? 2. And what was the client SGT which it got? 4, right? So what is the meaning of this? The fabric edge, upon receiving the DHCP discover packet, client sends the discover to the AP, and AP encapsulates that in VXLAN tunnel and sends it across to the fabric edge. The fabric edge re-encapsulates it. And fabric edge is a trusted device. And for trust device, we do have generally SGT2. So it is being generated by the fabric edge. So that's why the SGT is 2. It is very important.
That communication does happen through the management code?
Via overlay it happens, right? Via overlay it happens as it happens for the wired clients. So it's the same way, okay? So this is something very important to take note of it. Now, let's have a look at offer packet. So here, this is one interesting thing, just in case if you don't know how to decode the option 82, this is how we can decode the hex codes. I've just noted down. Here, as I mentioned, the agent circuit ID and agent remote ID are the two important parts of the option 82. So circuit ID gives me the VLAN information. So that is the important thing for me out here. And the second, in the agent remote ID, the Lisp instance ID, L3 Lisp instance ID 4099, and this one, remote locator, or RLOC of the fabric edge is the important one. So this is how the exact decode of the option 82 happens. So you can always refer back this while you're troubleshooting. Now, the fabric edge sends the Lisp map register for the client IP and MAC. So these captures are taken on the CP downlink. So here we can see the Lisp map register which is being sent, and there is an acknowledgement for that as well. And at the same time, this AP sends the announcement of this IP through the WLC, saying, client has got this IP, so you also take note of it. So WLC takes notes of it, and what it does, it adds that into the device tracking database, right? And gets into run state. That run state is very important. Run state and device tracking database, right? So that is the final thing. Same thing we can see in the RA traces, right? So here you can see the SISF, which is the process responsible for device tracking database. That puts the entry into the device tracking database and also associates that with the L2VN ID out there. So this is something which you can see in the RA traces. Now, let's look at the client onboarding troubleshooting. So again, we start with Catalyst Center checks. So in the Catalyst Center check, we can go inside the Catalyst Center, and there is a search option on the right-hand side where you can just put your Mac and look for Client 360. In the Client 360, in the event history you can check, or in the graph out there you can check what is the activity with respect to the client. In the same flow, we start with WLC checks. And here, one of the very important commands is show wireless client summary. In this, we can check if the client is in run state or not, and where this client has connected, to which AP it has connected. This information we can see out here in this case. Not only that, another very important command which gives a lot of details is this particular command, show wireless client MAC detail. Here, I have just done the section for Fabric Edge just to showcase the 3 pieces of information which are being forwarded to the CP, right? What are those? RLOC, VNID, and SGT. These are the pieces of information which are passed on to the control plane node, right? So this we can see. Sometimes I have seen in the field that SGT information may be goofed up, or it has not got from the ICE, right? This can be a problem. So, and finally, when the client joins, what happens? It is updated in the device tracking database. So this command, either of the command, show wireless device tracking database MAC or IP, gives me the information if the client has been added into the device tracking database on the WLC or not. That being the final thing, we can always get to know, about the client and this state reachable is very important out here to look at, right? So please do look at those things for the troubleshooting. And very quickly, again, like in case of AP join, we need to ensure that fabric status is enabled on the WLC, and it is having Lisp sessions with the CPs. Not only that, if you remember, in case of AP, infra v1 was being used. Here in this case, the corp v1 is used, and that's the name of the IP pool, okay? And the L2VN ID. We need to take note of this, and it should be in line. Now, sometimes what happens is there can be a situation like either I am joining my client for the first time, or maybe during the production hours I am trying to join, and then the problem is happening. In both the cases, it is very important to ensure that configuration is all good. The configuration which is being pushed by the Catalyst Center is present on the WLC, and that we can see from the graphical user interface of the WLC. So here in this case, for the client, 3 tags are very important. What are those tags? Policy tag, site tag, and RF tag. So we can check that those tags are intact or not out here, okay? And the same information we can check from using this command, show AP tag summary. So this is another command which you can run on the CLI and get the equivalent output, right? Now, let's say I want to get into the AP and check. So in that case, AP join profile under the site tag. In that, we need to enable SSH and add username password to get inside the AP. As we have spoken about AP, let's check what to see on the AP. On the AP, it is very important to see two things under this command. Show controller .11 radio 0 WLAN. In this, very important to see is the SSID, this SSID, and what is the state. Is the SSID and the state up? That is important. And one more thing, I want to highlight everyone out here. This SSID is fabric tunneled. This bridging type should be fabric tunneled. You may wonder, what is this CapWeb tunneled? This SSID, I have created another SSID actually, just to showcase the difference. This is non-fabric SSID. Non-fabric SSID would be CapWeb tunneled, whereas fabric SSID would be fabric tunneled, and that is what being sent by the AP, broadcasted by the AP, right? So that's something very important to note out here on the AP. From the AP perspective, you can also check this. So moving on the fabric, there are commands like, okay, CDP, if AP is all good, because AP needs to be up for the client to also, join in, right? So show CDP neighbor, we can check, and apart from that, show device tracking database. In that, it should be reachable. The client should be reachable. The AP should be there, and it should be reachable. Access tunnel summary in this, again, as I mentioned, here, the uptime is very important. And that with AP. And if you remember, SGT information was being sent from the WLC to the fabric edge via the CP, right? And then after, policy download happened. When the policy download happened, is it properly downloaded? How we can check? That we can check with this command, show CTS role-based permissions. In that, the permissions, we need to see the permissions are good. It is being permitted, or else communication may not happen, right? And at the same time, this another command, show CTS role-based counters. In this case, this counter, HW permit, hardware permit, right? And software permit should have counters. And we should not have these counters for the respective SGTs. So this is something really important to notice and take note of it while troubleshooting. And yeah, show VLAN. As we have seen in case of AP as well, in show VLAN, this VLAN name, which is associated with the L2VN ID, that needs to be again added in the ICE. Let's say I am doing the authentication and authorization. At that point, this VLAN name is added in the authorization profile, which is mapped to the policy. If somebody is here from ICE, anybody from ICE out here? Yeah, so in fact, you can use the authorization profile also. We will see a case scenario. I will just show you in next couple of slides. In few slides, we will see that scenario as well, how we can use that. In those cases, this is very important, and this exact name is important, right?
There will be additional config on the switch port where the access point is connecting?
Yeah, that configuration would be already pushed by the Catalyst Center. So you need not to bother too much about that. So that is the thing. And we can also check the running configuration where we can see if the VLAN is mapped over here. And very quickly, the SVI configuration is intact or not, and the loopback is good. And take note of the loopback. Very quickly, we can also see the same information from show IP interface VLAN. Here in this case, the important thing to note is MTU. Is MTU 9100, and the VRF is mapped over there. Apart from that, show Lisp session. In that, we can see if Lisp sessions are up from the fabric cache to the control plane, right? So we are having two control plane nodes. So here we can see both the control plane nodes are up, and what is the uptime out here. So those things are very important to take note. Moving on to the control plane node. On control plane node, again, the same thing. But here in this case, control plane node is in the middle. And it is having Lisp session with the WLC and the fabric edge. So in that case, we need to take note that it is up with both, right? So that is very important. And again, uptime. Uptime is something we need to check. And this is one very good command. Please do take note of it. This one, show Lisp instance ID, the instance ID, L2 instance ID, Ethernet server, registration history reverse. You may ask, why reverse? Here, reverse gives the latest information on the top. That's why we use reverse keyword. And take note of this plus symbol out here. It shows which client got registered recently. And if there is a plus sign, that shows it is registered. If there is a minus sign, it shows it got deregistered. That can be indication of a roaming. We will see more details going forward. So here, we can take note of the instance ID from where it got, there, what the time, and the EID, of course. Now, with that, we have come to end of client onboarding flow. If you have understood the client onboarding flow, it would be very easy to understand client roaming flow. It's very similar. Only difference is the movement. Client moves from one node to other, or one AP to other, or one AP to other AP which is connected on two different fabric edges. That's the only difference. Rest, everything is same. Let's have a quick look at the flow. Here, I have just noted down the changes from the client onboarding flow in the yellow color. You will see all the things are same, only the changes are highlighted in yellow. So here, client association also happens, but there would be a re-authentication which will happen in case of roaming. That's the difference. Apart from that, Lisp map register would be sent for the client MAC, and it would remain same. Lisp map notification would be forwarded or sent from the CP to the FE informing about it, and L2 forwarding table is updated. Policy download from the ICE. Let's say, just imagine, the client has moved from edge 1 to edge 2. I mean, the AP which is connected to edge 1 to AP2 on the edge 2. So in that case, on the edge 2, there could be SGT already present or not. Let's say if it is not present, in that case only the policy download will happen. Or else, policy download will not happen. Yeah?
Question in regards to the WLC to WLC re-authentication. For an example, you have two WLC of the same fabric. And if you have configured already the mobility, the internal basically, so then re-authentication should not happen, right?
Yes.
It was just work.
Yeah.
So that means in that point of view, the client roaming perspective, that re-authentication step won't.
Exactly. The question here is, if there are two WLCs and they are having a mobility configuration, in that case, the re-authentication will happen or not. It really depends, right? And if mobility configuration is there, it should not happen over there, because it will take care of it from that based on that configuration, right? But just in case if there is a disconnection, complete disconnection, and then reconnection happening for the client, in that case re-authentication will happen. So it really depends on situation to situation. We can discuss in more detail after the session if you are having more questions out there. So there are many variations to that. That's why. So that's the thing. Now here in this case, the client gets the IP after that. So here in this case, the discover and offer may or may not happen based on the lease time. Let's say if lease time is high and it has not expired, in that case, this discover and offer will not go. Only the request and ACK will happen. So that's another change. And anyway, device tracking database would be updated, and list map register would be sent for the client MAC and IP. And finally, AP sends the IP, announcing it, and client moves to the run state, updating device tracking database on the WLC. That is the process. Okay? Now, the same thing we can see in the array traces as well, right? Where we can see out here, the reassociation has been received, right? And there is, IP learn happening, and success roam is happening. In this message, you can see. So these are the details. Now, moving on to the client roaming troubleshooting. The packet walk remains same as what we have seen in case of client onboarding. So that's why I have not repeated all those things out here. In troubleshooting also, most of the troubleshooting what we have seen in case of client onboarding remains same. There are few more commands which we may have to use in case of client roaming flow. Okay? First, WLC check. Here, one of the important commands to check is show wireless client MAC mobility history, that client and mobility history. If you see out here, take note of the association time. That shows when the client got associated and when it moved to the next AP. So here, AP names are different, if you can see. And the association time, right? So it got associated at 2010, and then it moved to the another AP, AP2 on S2 at 2030, right? So this we can see with the timestamps in this command on the WLC. So this is one important command on the WLC to check. And not only that, the same information we can check on the control plane node as well. On the control plane node, it is very good command. As I mentioned earlier also, in case of client onboarding, this show Lisp instance ID, the L2VN ID, and Ethernet server registration reverse, right? Here in this case, you need to take note of this plus and minus and plus symbols. So from that, you can actually get to know where exactly the movement happened. So if you take note of the IPs out there, which fabric edge has registered that or deregistered that, that information we can see. Plus sign is for registration. minus sign is for deregistration. That means earlier my client was on 84.104, the fabric edge with IP ending with 84.104. On that, the client was present. And then it moved to the fabric edge where IP is ending with 84.105. Right? That's what we can see out here. Now, with that, we have come to end of our flows, PacketWalk, and troubleshooting. Here, now on, we would be seeing some scenarios, which and a list of commands out here. So we would be covering 2 scenarios quickly. Scenario 1, AP is not joining. Here, I am just covering a scenario which I have not precisely covered earlier. The one with ICE. The one with ICE. Here, just in case the dynamic AP profile is not matching and misconfiguration is done in the policy set and authorization profile. In that case, where to check? We can go to policy and policy set, and there we can check in the authentication policy, and after that in the authorization policy. In the authorization policy, we can create the rules and have the profile out here. Have the profile, okay? And the security group tag mapped. Take note of this profile out here. So this, and this one, this security group tag, we can create going to the work center and TrustSec out here in the ICE. So these things can be mapped in the authorization policy, and from there, that authorization profile, which I mentioned, right, which was mapped at the back of it. If you see here, this was mapped here, right? So if you just go to the authorization profile, in the policy elements and results, in the same authorization profile, if you just go down, it needs to be, access type should be access accept. And very important, the VLAN name. The VLAN name, if you remember, from the edge, the VLAN name, the same name has to be here. Same name, right? So that's how the things tie up. So it's very important out here.
This tag ID doesn't matter, right? Because
Sorry.
the VLAN number would be different, but if you go with this tag ID.
That tag ID don't matter. Only thing is this name, okay? Sometimes, let's say, if name is not being detected and there is a problem, at that point in time, you can even try the VLAN number and try to troubleshoot. That is another way to check, but it's always recommended to have the VLAN name, which we see here. And remember, you can see this on the Catalyst Center as well, right? So same thing. Now, let's move on to the second scenario. If those things actually taken care in the scenario 1, it should be all good from the ICE perspective. I just wanted to touch base on the ICE as well because that is one of the components. But so with that, things would be taken care, right? Now, let's move to the scenario 2, where client stuck in IP learn state, and client is abandoning the auth process. So here we can see client has not initiated the DHCP process. So what is happening? You need to take care of one important thing with respect to the clients. What happens is, client also have timers, okay? So in that case, client may not move into the association if there is a delay from its end beyond 200 to 350 milliseconds. In that case, we need to troubleshoot the client side, right? So if there is any client side delay, then it's not a network delay problem. After all, it's not always network, right? So this covers all the different scenarios, right? We have touched on the Catalyst Center, the WLC, the AP, ICE, and even the client.
Is there a scenario so it's an issue on the client. But is there a possibility that the access point is not does not associate the client?
Yeah.
How do we troubleshoot that?
Yeah. In that case, you can take the OTA captures on the AP, and from there you can get hold of it. The question is, let's say if it is not the client problem, but AP in between is dropping out or delaying the things, then how to check? In that case, the answer is we can take the OTA captures, and from there we can get hold of the things. Is it client problem, or is it the AP or the network side problem? Yes.
There's another one, which is not in client side of the problem. So what happens, neither the AP, and I think from the DNX center is like I would say somewhat of kind of a generic statement, like, there is a delay in AAA server responding to the request. But when you actually go through in ICE, radius lag logs, and when you're going through it, 90% of time you find it out that ICE have already passed an authentication and sent in request to an WLC side. But I think from WLC to an AP perspective, it haven't received anything, or by the time it has received, the client have already started a new session.
Yeah.
This is something I have seen common incident in legacy as well as in SDA environment.
Yeah.
So how do you
remember the question is, sometimes a lady has seen the delay in the overall process where the client resends the association before it gets authenticated. In that case, one of the things which we can check, in fact, in the start itself, at the start, I noted about the latency figures, right? That's very important. Sometimes those things also play. That can be one of the variables, right? There can be other things which could be coming. We can discuss more after this session because we are getting delayed, and I do have some more slides to discuss so that we complete on time, right? So as I mentioned, it's not always the network problem. So please do take note of it. So many times I have seen it's not always network problem when after troubleshooting, right? So now I've just posted some useful commands and debugs out here so that you can go back, refer to this while you're troubleshooting. And in fact, some description is also there, like on the first command, it is for those commands can be run on control plane node. And the first command, let's for example, show Lisp instance ID, L2 AP instance ID, Ethernet server, that is giving MAC to endpoint mapping. So bit of explanation is also there. So I just dumped all the commands out here and the debugs, right? And where to run those commands. So you can always use these commands, some platform commands, some debugs out here. So that's something which you can use while you're troubleshooting always. Now, the best practices and some troubleshooting tools. Here in this case, I would like to highlight some best practices very quickly. In fact, we have gone through this and discussed these things during our entire session till now. Okay? The first and foremost thing, the important thing, many times I have seen, almost more than half a times, the specific route of the WLC should be present in the fabric, in the global routing table, and that is missing. Due to that, what happens is, when the routing is taken care, there can be a situation where it would be having default route or some loops in the network due to misconfiguration or some changes which could have been done. Due to that, in the absence of specific route, there could be problems. And this can be one of the problems for the problem which the lady has mentioned, the latency problem. Sometimes if you are having in-between loop or some route missing, in that case, we may find this. This could be also one of the indication of that problem, right? So due to that, that might be happening.
Isn't that just for reachability? So the control plane knows that the wireless control.
Exactly.
So there's not a loop problem really. It's
No. Actually, I will tell you. I will share my experience. In fact, I was troubleshooting one of the scenarios, okay? And in that, the latency was creating the problem, okay? And when we troubleshooted and found that there was some change with respect to the node, intermediate node, right? The intermediate node was shut down due to some maintenance, and it was removed in the process, right? But from the fabric edge perspective, there were other paths. But when we are having this, in that case, we were having this default route only, not a specific route. Due to that, there was, load balancing happening, and that was not happening properly, and there was a kind of loop situation which was, created due to that maintenance window which was taken, right? And that device was removed. Due to that, ultimately this latency problem was happening. So some of these things, I'm just trying to tell you that some of these things can also be indicative of those things. I'm not saying always it's the one, but this can be one of the things. Now, moving on very quickly, I hope that answers. So, in fact, I'm just telling you, I have seen this scenario also in one of the troubleshooting scenarios. And not only that, your APs should be in infra VN. That we have discussed, and there should be obviously connectivity, and ping should happen. Apart from that, fabric status should be up with the control plane node. WLC and control plane node should have that fabric status up, and it should be fabric status should be enabled. Wireless network profiles and SSID should be configured properly from the Catalyst Center. The pools, wireless IP pools like AP pool and client IP pool should be mapped to the respective VNs, right? And very important, sometimes we forget to have the provisioning redone or reprovisioning done upon some change, and then expect, okay, I have done this change and why it is not reflecting. So we need to do the provisioning again also. And AP should be in fabric enabled state. That is very important. Now, let's move on to some tools. These tools are very useful while troubleshooting. One of the very important tools in Catalyst Center, I'm not sure if you have used or not, but fabric data collection under the network reasoner in the tool section is very important. Here, you can navigate into this and go into that fabric site, simply select the devices which you want to do. It is always advisable to select the control plane nodes along with the edge and the WLC, and then simply do the troubleshoot. Hit the troubleshoot. There would be a output which would be just coming after this, and let's say if you are having 10 devices, just per se, you want to take the outputs, it collects around 50 to 60 commands from all those. And for 10 devices, it could be just taking 2 minutes to collect all those outputs. You can always go back, download those things, and look at those command outputs, and it would be very easy to troubleshoot. Now, as we have seen during our discussion, RA traces. We have referred to RA traces also. I just want to tell you how we can use those RA traces or other troubleshooting tools on the WLC. If you go into the WLC troubleshooting section, then you will see a lot of different tools out here. One of my favorites is radioactive traces and packet captures. So these are some of the important tools which we can use. And even in case of RA traces, you can see how we can take the RA traces. Just for example, if you go into this troubleshooting, then radioactive traces, there you can just add the MAC or IP and start the trace. And from there, you can generate the trace. When you are generating the trace, always remember, it's good to have enable internal locks over there, right? That gives additional locks in the array traces. So please do that, and also generate it. After generating, you can download and take it onto your laptop. So this is something which you can do very easily and go through the logs yourself, like a TAC engineer. Some more tools towards the end are assurance dashboard. We have seen this. We have discussed this also. Apart from that, the network reasoner, just a couple of slides back, I have just mentioned about it. In fact, this link which is given out here, this is having the details about a script or a tool which is embedded in this link itself. And that, for that tool development, I have been also part of it. I have tested that tool as well. You can use that, go through that link and use that tool for easy analysis of those logs which are generated from network reasoner. So that is something you can do. OTA. You need not to go and do the OTA directly on the AP and or maybe carry the laptop and do the things. Now OTA is available on the Catalyst Center. So this link here is referring about that. Span captures, just telling about how to take the span captures in this link. Apart from that, wireless troubleshooting tools. Here, there are a host of troubleshooting tools which are mentioned as part of this last link. One of my favorite one is this one, wireless debug analyzer. This gives the pictorial view of the logs. It just analyzes that and tells where it could have broken or how the things are working out. So that is something which we can see out here in this case. So with that, I come to end of my session out here, and I would like to quickly recap out here. We have gone through briefly about the architecture overview, the basic workflows and troubleshooting, where we covered 3 workflows, that is AP join workflow, client onboarding workflow, and client roaming workflow, where we have gone through the packet captures, packet flow, and troubleshooting, what exactly we can troubleshoot. You must have seen very common commands which you use in day-to-day life, but it's just about correlating those things. Just correlate, and from there you can get hold of what exactly is happening. Not only that, we have gone through a couple of problem scenarios which we may not have touched during the packet flow, but I just covered those additional scenarios also. And we have also gone through some of the useful commands, list of commands and debugs, which we can use during the troubleshooting. And finally, we have gone through some best practices and the tools which we can use as part of our troubleshooting. So that's where my session ends today. Thank you for listening, and I hope it has been useful for you. And again, thank you. Thanks for joining this Cisco Live, and welcome again to the Cisco Live. Signing off, here's your LG. And yes, please do complete the survey. You will be getting a t-shirt. And always, you can continue the education going on to the on-demand library of Cisco Live and get hold of various other resources. Thank you. Thanks.